All right, let's start section 3.2, which is about complex numbers. And if you're saying, well, what are complex numbers? In the hierarchy of numbers right here, and if you look at our little flow chart, complex numbers is everything. It's at the very top. So now, most of the time, what you've been familiar with is everything that's on the left-hand side, where it drops down to real numbers. And real numbers is a pretty big, uh, selection of numbers as well. It's almost everything else. However, if we break it down, real numbers turns into what could be rational numbers. And if you remember, rational numbers are, let's see, we'll say numbers that can be a ratio, meaning we could turn it into a fraction. So 1/2 would be considered a rational number. Okay, zero point 0.5, you could turn that number into 1/2 for it to be a rational number. And then after that, another type of real number would be an integer. Those would be, positive, negative, whole numbers. Okay. Whole numbers right there. I guess we can go ahead and you should know what whole numbers are, like 1, 2, 3, 4, 5. No fractions. And then we have natural numbers. That right there are positive whole numbers. All right, so all of those are considered real numbers. Now, if we look on the right side of real numbers right here, we have irrational numbers. For example, pi. Because you can't take a number like pi and then it keeps going, right? There's no end. You can't really turn it into a fraction, okay? Because it doesn't work out. There's no way to get 3.1415, etc., and be able to come up with a fraction like that. So irrational numbers will be something like pi, um, or I guess formally we could say cannot be expressed as a ratio, meaning you cannot write it as a fraction. So now what we take a look at today, or the big thing right here, is imaginary numbers. That's the new item right here that you probably never heard of until now in Algebra 2. And imaginary numbers are not numbers where that they don't show up, they disappear like a ghost. The imaginary unit I is defined as, and then they show you right here, I is equal to the square root of -1. If you remember, probably when we were doing, when you've done, use the quadratic formula, we had inside the quadratic formula was b squared minus 4ac, and we called this the discriminant. And if it was positive, we had, hopefully you remember, there was 2 solutions. If it was 0, there was 1 solution. And then if there was negative, that means that there was no solution or no real solutions. Okay, so now what we're going to be able to say is that there are 2 imaginary solutions when we start solving problems. So what happens is that this part becomes negative, but then, like I said, in Algebra 1, when that was the case, we pretty much said, hey, we're done, right? There's no real answer, so we can go ahead and quit. But now in Algebra 2, we will take this one step further and understanding that this right here, the value of I is equal to the square root of -1. So now we realize what complex numbers are. We have 2 sides to it. right? We have your real numbers and imaginary. The real numbers is probably what you're familiar with. Imaginary is something new. Probably the main thing right here in our vocabulary, in the imaginary unit, we use the variable I. When we talk about complex number, it is written in standard form, or written in standard form, it is a plus b times I, where a and b are real numbers. So you may see I in your answers, okay? And that's perfectly fine. So let's see what happens right here when we actually try to do some math dealing with imaginary numbers. If r is a positive real number, then the square root of negative r is equal to I rad r. So in Algebra 1, you should have been told that we can never have negative inside of the radical, which is true. Once that happened, we usually ended up with no solution, or we just ended it right there. But now what we're going to do is take it one step further. Since we can't have the negative, what we're going to do is this. If remember, it said earlier, it showed that right here, I is equal to the square root of negative 1. Well, if you look right here, remember, in front of the r is a negative 1, or is a 1. So what we end up doing right here is taking this negative 1, and we set it equal to I. We put it on the outside. So I can go ahead and take the square root of negative 1. It becomes I. It's on the outside, and then we leave rad r inside. So right here in our example, if I were to split this thing up, remember, it's negative 1 times 3. That gets me negative 3. So if I take the square root of negative 1, that's where the I comes in, and we put that on the outside. I cannot take the square root of 3, so we go ahead and leave it as is. And there you have it. Taking a look at number 2. Now, remember, if you have parentheses and an exponent, your best bet, especially right now in the beginning, is to realize that, hey, this right here, I need to expand it out. Because now what happens is this. If I get I times I, that gets me I squared. And then right here, rad r times rad r, when you multiply radicals together and it's the same on the inside, it's going to equal itself. So we have I squared times r. All right. Now, I'll talk about this next step later, but I squared is actually equal to negative 1. And you're saying how and why? Don't worry about it quite yet, but I squared is equal to negative 1, and what we end up with is negative 1r, or negative r as the answer. So that's why right here, if we take a look at this in the example, let's expand it out, right? I'll go ahead and write this down. I rad 3 times I rad 3. I times I is I squared. Rad 3 times rad 3 is rad 9, which equals 3. So then once again, I squared is equal to negative 1. And then right here, we have ourselves times 3, which equals negative 3. Okay. So then, it comes down to this. You're saying, well, how did I end up with, let's say, I squared equaling negative 1? Well, how about this is going to be one of those things where it's just going to be easier for you to just memorize it. Okay? So, I want to go ahead and show you 4 things. We have I to the first. And anything to the first power, hopefully we realize it's going to be equal to itself. So this is going to be equal to I. We have I squared, which we just talked about right now. That's negative 1. We have I to the third, and that's going to be equal to negative I. I to the fourth, that right there is equal to 1. Okay, so these right here, these four are absolutely important. It's easiest just to memorize it, to realize, all right, I to the first is I to the I squared is -1, I to the third is -I, and I to the fourth is 1. So now let's check this out. What happens if we have I to the fifth? Well, that's going to be equal to I to the sixth, that's equal to -1. I to the seventh, that equals -I. And then we have I to the eighth, and that's going to be equal to 1. And guess what? That's going to repeat. If I go ahead, for every 4, right here, I to the ninth, that's equal to I to the 10th is equal to -1. I to the 11th equals -I. And I to the ninth, or sorry, 12th, that equals 1. So I could technically say, all right, what is I to the 87th power? And you're saying, well, how do I figure that out? Do I need to go ahead and write this list out? No. The easiest thing to do right here is to take whatever the exponent is and then divide it by 4. Okay? So the first thing you do need to do is memorize these right here. Okay? So you better memorize this. Because to get the rest of the answers, you have to base it off of this. What do I mean? Well, let's take a look. If I said I want to figure out what is I to the 87th power, what I'm going to have to do right here is let's take 87, we'll divide it by 4. Okay, so right here I get myself 2, that's 8, and then we have ourselves 7, 4 goes into 7 one time, and then we have a remainder of 3. What I'm going to do right here is take this remainder of 3, and that's going to represent my exponent. Well, which right here, I to the third power is -I. So that tells me that I to the 87th power is -I. And there you go. Something you could try to practice with. How about this? Let's have, we'll make it easy, or a little bit smaller. We have I to the 15th. Okay. So what I'm going to do, we'll take 15, we'll divide it by 4. Okay, so 4 goes into 15 3 times, and we have once again a remainder of 3. That 3 right there will represent I to the third power, so I to the 15th is actually equal to -I, once again. Alright, so that is the easy trick to figuring out what is the imaginary number to whatever power, 1, 2, 3, 4, etc., divided by 4, whatever the remainder is, line that up with one of these 4 answers. All right, so you have to once again memorize and understand what's going on there with I to the first all the way to I to the fourth. All right, moving on. Okay, sum and differences of complex numbers. Pretty much what they're saying here is this. In order for you to add and subtract two binomials, you can only add or subtract like terms. So like right here, I could add A plus C. Those happen to be numbers. We have B to the I plus D to the I. So that right there, you could actually add these two up right here because they have like terms. They're both imaginary. And then so what they end up doing right here, though, is they took BI plus DI. And then if you look, what they did from what I have right there in green and right below is that they factored out the I. And that's why the I happens to be on the side. So it says to add or subtract two complex numbers, add or subtract their real parts and their imaginary parts separately. All right, so we want to find the square root of some of these numbers for our practice right here. Okay, you've got to be able to simplify radicals as much as you can. All right, so right here, I've got myself the square root of 49. And hopefully we realize that, okay, First, we want to be able to get -1, okay? Because remember, the square root of -1 is equal to I. That's something that I can work with. So right here, I've got -1 times 49. Right, that equals -49. I could take the square root of -1, which we said is now I. And then the square root of 49, that is a perfect square. And that gets us 7. Right, square root of 49 is 7. We've now simplified that. Taking a look at number 2, right, I could split this apart with -1 times 4. So the square root of -1 is I. The square root of 4 is 2. And that's the square root of -4. We get down right here to number 3. Now we have square root of 45, which is not a perfect square. So you have to think, well, what are some numbers or perfect square factors of 45? Well, I like right here, how about -9 and 5? So we could separate this, the square root of -9 as -9 times 1, but hopefully as we get better at this, we realize, all right, if I could take if it's a perfect square and it's negative, then that'll get me I. So the square root of -9 will be 3I. The square root of 5, I can't do anything about that. That will stay on the inside. And there's our answer, 3I times rad 5. Let's take a look right here at number 2 or number 4. So we've got right here -2 times the square root of -100. Think. All right, -100, that happens to be a perfect square. So in this case, you can go ahead and take the square root of 100. Hopefully we realize that that is 10I. Now don't forget, we have this 2 that's on the -2 that's on the outside. So you better make sure now we multiply with what's on the outside. So don't forget, boys and girls, remember, if you are able to simplify and take a number out of the radical, then you have to multiply it by whatever's on the outside. So this right here ends up becoming -20I. We'll take a look at number 6. So hopefully right here, with the square root of -75, how about -25 times 3? The square root of -25, that's a perfect square, so it becomes 5I. So we have 5 times 5I times rad 3. And don't forget, if there's already a number on the outside, then you have to multiply the two together, and we end up with 25I rad 3. And there you go. On number 7, if you see some problem like this, remember, pretty easy. Remember, you could only add or subtract things that are alike. So what we're going to try to do right here is actually, let's take this -10x in the first position, and let's set it equal to 30. And then we're going to take the I that is in the second position, we're going to set that equal to right here. I is equal to -y times I. And we're going to go ahead and just simplify this and solve for x and y. How about this is one of those things, you just set it up and solve it up. Okay, so whatever's in the first position of the two sides of the equal sign, set it equal to each other, and whatever's in the second position, set them equal to each other. So x right here is equal to -3. We have right here -y is equal to 1 because I divided by I is 1, and y is equal to -1 when we divide that to both sides. All right, easy peasy. Let's go down right here to the next page. So they asked for two things. One, simplify the expression, then classify the result as a real number or imaginary number. Okay, and then specify if it's a pure imaginary number. So remember, in the very beginning, we came down with the list of um, real numbers and imaginary numbers. Okay, remember they're all under the family of complex numbers. So let's go ahead and start simplifying things. And remember, we can only simplify terms that are alike. So this -8, I could add that up with -1. Okay, so we have -8 plus -1. And then right here, I could take the 3i and I could add that up with -2i. Okay, so 8 plus -1, that right there is -9. And then we can go ahead right here, we'll put the plus sign, and then 3i plus -2i, that right there will get us I. So I have 9 plus I. We have I in our expression, so that should tell us that this happens to be an imaginary number. Okay, so this one is imaginary. If there was no I, then we can go ahead and say that it happens to be a real number. All right, but that's not the case right here. Let's drop down to number 11. Okay, so let's go ahead. I see 16 plus -16 right there. And you're saying, where's the plus? It's right there in between the two. So that equals 0. Then we have I plus -8i. That right there will get us -7i. All right, so now what we end up with right here is just -7i. That would be our answer. Now in this instance, because we don't have any real numbers in the answer, this one will be imaginary, but we'll go ahead and say this is pure imaginary. All right, so if there's no real number in the expression, then it is considered pure imaginary. All right, let's take a look at number 14. Now 14 looks a little bit different. Pay close attention right here. There's no plus sign in between the two binomials, so you're going to have to FOIL this. Okay, you got to multiply the two binomials, 13 times 13. We have ourselves 169. We have the outer is -13i, and the inner plus 13i. The last is -i squared. So we got -13i plus 13i, that is 0. So I have 169 minus I squared. So you think you're done, right? But we're actually not. If you remember, we talked about when we have I to the first, I to the second, I to the third, I to the fourth, what do things equal? And so you have to take that into consideration now into these problems. They have that one little extra, I guess, thing that you have to remember, because things aren't hard enough as is, right? So remember, I to the first, we talked about what they all equal, right? In case you forgot, we have I to the first is I. Remember, we have I to the second is going to be -1. I to the third is equal to -I. I to the fourth is equal to 1. So I see right here I squared. Well, I squared is equal to -1. So what I'm going to do right now is take 169. I want to subtract that with -1 because I squared is -1. So we went ahead and substituted that in, okay? And you can see why I have the parentheses there. Definitely important, or else you might just say 169 minus 1. That would be wrong because there's already a minus sign in between. So 169 minus -1, and that gets us 170. Okay, so don't fall into the trap of missing that. And then right here, quite simply, we go ahead and they'll ask you, is this real, imaginary, pure imaginary? Well, it's just a number itself, so that makes this a real number. All right, the last part right here is being able to solve equations. Okay, it's what you did in chapter 2. You took your quadratic function, set it equal to 0, and you could find the zeros. Right? There's several ways that you could do it. You could either factor, or you could um, use square roots. It all really depends. But now we could actually uh, solve for x by using square roots all the time, because now we know that, hey, I could solve a negative radical. So let's do that right here. I'll go ahead and subtract 25 to both sides, and I got 25 is equal to 5x squared. Next up, divide both sides by 5, and x squared is equal to negative 5. Before, we would have a problem right here. But now, because of what we could do with imaginary numbers, all right, we'll square root both sides, and now I have x is equal to the square root of negative 5. Now, the big thing is, don't forget, there should be two answers. So we can say plus or minus the square root of negative 5. Okay? Do not forget that. Now, I cannot leave negative 5 or negative number in the radical, so we're going to go ahead and use our imaginary numbers. And remember, I could split this apart with square root of negative 1 times 5. And the square root of negative 1 is, hopefully you know, it is I. So my answer is going to be plus or minus I rad 5, and that equals x. All right, let's go ahead and take a look at number 17. We could set this equal to 0, try to factor and solve, but I don't think that'll work out. So what we're going to do is let's get x squared by itself. I'll go ahead and add 10 to both sides, and I end up with x squared is equal to negative 8. So now things start to look like what we had in number 16. We'll square root both sides. X squared is equal to the radical negative 8. And let's see if we can simplify this. I know that right here, I've got negative 4 times 2. And negative, or 4 is a perfect square factor. And don't forget, we also have the plus or minus right there, right? If we square root both sides. So x is equal to plus or minus rad negative 4 times 2. Let's simplify that. The square root of negative 4 is going to be, hopefully we realize, plus or minus. And we got ourselves 2y times the square root of 2. And that is x. All right. So there you have it. You now know how to solve equations. You now know how to deal with imaginary numbers. But don't forget, you've got to make sure you remember the list of at least I to the first, all the way to I to the fourth, so that later on you can figure out the imaginary number answers for all types of, regardless of the exponent. I to the 100th, I to the 500. Remember, take those exponents divided by 4, and whatever the remainder is, apply to either I to the first, I to the second, third, or fourth. All right.